This is Algebra 2, Lesson 5.1. This is part number 2. We're picking up with box that talks about the vertex and intercept forms. The first form we talked about was standard form, y equals ax squared plus bx plus c. The next form is the vertex form. This one's a lot more useful because you don't have to find the vertex with this one. You can see it when you look at the form of the equation. Y equals a times x minus h. This minus right here is key. We'll talk back about that minus in a second. Minus h squared plus k, where the vertex is h and k. I don't know why. I'm sure there's a reason, but I don't know why they use the variables h and k. What you need to assume, or what you need to remember is that this is the x value and this is the y value of your vertex. So when it's in this form, you can see what the vertex is right away. The minus right there tells you that it's the opposite of whatever this one is. So when you see -3, like if it said x minus 3, you would know that it's going to be a +3 for your x value. So in this case, the axis of symmetry is h. Or again, it's whatever that value is in place of that h. That will be your x value of your axis of symmetry. The intercept form is y equals x minus p times x minus q. Again, the x-intercepts are p and q. This one is your x-intercept, and this one is your other x-intercept. Notice there's no y-intercept. We're not talking about the y-intercept. Remember, with your parabolas, when you're talking about a parabola here, it's going to look like that, and it could be shifted any direction, up or down or left or right. But this is one of your intercepts because that's where it's crossing through the x-axis. This is the other x-intercept. So when it's in this form here, it shows you the p and the q value in this case, show you the value where it crosses through the x-axis. So if that said x minus 3, then you would know that one of the intercepts would be 3, and the other one said x minus 8, the other one would be 8. So it would be at 3 and 8 is where it crosses through. So for both forms, the graph opens up if a is greater than 0. So if a is positive, and it opens down if a is negative. So that is still true. That's the same as it was in standard form. If it's positive, it opens up. That's this way, like a U. If it's negative, it opens down. That way, like an upside down U. So that's just two other forms. The first one we talked about was standard form, and we'll get plenty practice at this. Standard form. The other two are vertex form and intercept form. The vertex form is the more useful out of the two, but both of them have their uses at times. Example number 2 is graphing a quadratic function in vertex form. Watch how much easier vertex form is. So let's highlight a couple of things. We have this value here and this value here. This is vertex form. Y is equal to 2 times x minus h squared plus k. This is the opposite of your x value. Remember, whatever's in there, it's the opposite. And this is the exact value of the y of your vertex. So your vertex here would be the opposite of -3. What's the opposite of -3? 3. And it's exactly what we have for y. What does it say for y? -2. So the vertex of that equation, just by looking at it, is 3, -2. So at 1, 2, 3, -2 is going to be the vertex of your equation at 3, -2. Based on what it says at the end of that box a minute ago, is this thing going to open up or down? What's the A value? Is it positive or negative? What's the A value? That's it right there. What is it? Positive. So is it opening up or down? So from here, don't trace this part. It's going to look something like that in a second. Okay, we're going to get the rest of it in just a second. So we know that's the vertex. We know it's going to open that way. And we know since it's the vertex, this is our line of symmetry right here. Remember, the line of symmetry separates it. It makes it exactly the same on one side and the other side. So 3, -2 is what it was. Let's go through all of this right here. I think I just did all of that. Not quite that far. Okay, the function is in vertex form where A is equal to 2, H is equal to 3, and K is equal to -2. Because A is greater than 0, we know it opens up. To graph the function, first plot the vertex 3, -2. We did that. And then draw the axis of symmetry where x is equal to 3. And plot 2 points on one side of it. Okay, remember, we have to slide one. We got to slide twice to where we can plot 2 points. Is it easier? And again, it's up to you right here. Is it easier to go to 2, or is it easier to go to 4? What's easier to multiply by, 2 or 4? 2 is, absolutely positively. They both are going to act exactly the same in regards to the axis of symmetry. Remember that. So use 2. So let's use this value right here and determine what our y value is going to be. So we're going to use this equation here, and we're going to say x equals 2. So now we got, this is a simple equation. Y equals 2 times, instead of x, 2 minus 3 squared minus 2. So 2 minus 3 in the middle we know is -1, and -1 squared is 1. So we have 2 times 1 minus 2. So 2 times 1 is 2 minus 2. So what's our y value going to be? Y is 0. So when x is 2, y is 0. And I didn't mean to circle that, but it just worked out that way. That point right there, when x is 2, y is 0. Okay, so what does our axis of symmetry tell us? When x's value is 4, what's our y value going to be? Remember, we shifted once to the left and we got 2, 0. If we shift once to the right, we're going to get 4 what? 0. The same. Remember, it's going to be exactly the same right there. So now we got to shift one more time. Is it easier to shift to 5 or to 1? 1 is absolutely easier to multiply by than 5. So let's use the number 1 now. So now x equals 1. Same equation. Y equals 2 times 1 minus 3 squared minus 2. 1 minus 3 is -2. -2 squared is 4. 2 times 4 minus 2. 2 times 4 is 8. And 8 minus 2 is 6. So when y's value is 1, when x's value is 1, y's value is going to be 6 right there. And what do we know? If x's value is 5, if we shift one time to the right, what's y's value going to be? So we shifted one time here, we got this. What if we shift one time here? What is our y value going to be? It's going to be 6 again. It's going to be right here. Remember, your axis of symmetry tells you that it's the same on both sides. So now that you have 5 points, it's as simple as starting at the one on the bottom, tracing through it, and starting at the one on the bottom and tracing through it. And now your graph is done. Again, I know this is a new concept. I know it looks exceptionally difficult, and some of y'all are looking at it and You look like your eyes are swimming. You have no idea what to do. It really is a whole lot easier once you do it a few times. It's really a very, very easy thing to do. What I think most of y'all are missing as I'm talking and as I'm looking at y'all, most of y'all are missing what I mean when I'm saying shift one way or the other. Okay, we're talking about your X value. If your vertex was right here, if that was your vertex, that means that your line of symmetry is right there as well. Okay, you have to shift to the left or to the right. It doesn't matter which one. Whatever one is easier is the one you want to do. You got to shift once to the left or once to the right. Right here, this value of X is 3. X is 3 at that point. We have to shift to this one, to this one, or we got to shift to this one. Both of them work just as fine. But which number is easier to multiply by? X is 4 or X is 2? That's what I mean by shift to the left or to the right. The number gets smaller, it's usually easier. It's not wrong to use X is 4. In fact, it's perfectly fine. Most of the time, it's just easier. A lot of times, you'll deal with 1 and 0 and -1, and they'll be even easier. So when you use that value, X is 2 right here, and you run it through the equation, you're going to get a value. Remember, wherever it happens to be, whatever it is on this one, it's going to be the same. That's what the axis of symmetry means. So then you have one more time you got to shift. Do you want to shift to 5 or do you want to shift to 1? Which one's easier to multiply by? 1 is typically much, much easier. So use X is 1. And when you run through the equation one more time, you're going to get another point for X is 1. And remember, it's exactly the same when X is 5. That's what I mean by shifting to the left or shifting to the right. And once you have 5 points, you can draw your parabola through them. Let's try another vertex one. In the blank space on your page, try to graph. Let's just graph right here the vertex and the axis of symmetry. Take about 30 seconds and do just the vertex and the axis of symmetry. Okay, look at the numbers you need to look at. Try to ignore some of the other numbers for right now. This number is important, and this number is important. They are your X and Y values of your vertex. Remember, though, your X is the opposite of what it says. What does it say up there for X? It says -1. So it's the opposite, which is +1. And it's exactly what Y says. What does Y say? 3. So don't make that mistake and put either both of them opposite or both of them the same. One of them is opposite and the other one is the same. Again, one is opposite and one is exactly the same. So the first thing you have to do is plot the vertex itself. This is your x-axis. So at 1, 3, this is your y-axis. 1, 3 is your vertex. Remember, that's either the top or the bottom of your parabola. Based on the picture, is it the top or is it the bottom? How do we know? Not based on the picture. I said the wrong thing. Based on the equation, it's the top or the bottom. What is the A value? It's this, 2. That's a positive value. So is this the bottom of the parabola or the top? Which way does it open? It opens up. So that's the bottom. So this one's going to go like this. So we have to determine exactly how it's going to go. So we got the bottom of the parabola. So we have the bottom of the parabola. So we want to shift one way or the other way. Remember, now we're at 1 for your x-axis. So you got your line of symmetry. Remember, it's going to be exactly the same on the left and the right. So we want to shift to the left and the right. Is it easier to multiply by the number 2 or 0? 0. So we want to run that equation with x's value is 0. So when x is 0, we got y equals 2 times 0. All I'm doing is plugging it in place of x, minus 1 squared plus 3. So 0 minus 1 is negative 1. Negative 1 squared is 1. And 2 times 1 plus 3 is 2 plus 3, which is 5. So your y value when x is 0, y is 5. So we were at 3, 4, 5. There is your point when x is 0. So here's a question right here. When x's value is 2, what is y's value? It's 5. It's the same. Remember, your axis of symmetry makes it exactly the same at that point. Now, my picture on my graph looks like I'm going to run out of spots in a second because it's going to be higher than my graph. We'll add them in just a second. You guys can just draw it in. So now, we want to shift one more time. Do I want to shift to negative 1 or do I want to shift to 3? What number is easier to multiply by? Negative 1 typically. Again, neither one of those answers is wrong. Both of them are right. Negative 1 and 3 are both right. But it's usually easier. We want to shift one more time this way or one more time that way. And whatever way you want to is fine. So negative 1 is typically easier. So x equals negative 1. We'll run the equation one more time. Y equals 2 times negative 1 instead of x minus 1 squared plus 3. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. So we have 2 times 4 plus 3 is 8 plus 3, which is 11. And that's what I meant by jumping off my graph right there. When x's value is negative 1, y's value is going to be 11. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to get that high. So when x's value is negative 1, y's value is 11. What about when x's value is 3? What is y's value going to be? 11, the same. Remember, the axis of symmetry puts it exactly the same right here. So this is what your graph should look like. Now that you have 5 points, you can trace through those and make it look like so. That's what your graph should look like. That's in vertex form. Okay, we have our first checkpoint problem right here. It says graph the quadratic function. It says y is equal to 1/2 x squared minus x minus 1. Now this is back to standard form. This is from yesterday. Remember, y equals ax squared plus bx plus c. In order to find what your x is equal to negative b over 2a. So what is our b value right here? It's negative 1 right here. So it's already our b value. It says it's negative b. It's negative, negative 1. Remember, negative, negative is going to be positive 1 over 2 times our a value. What's our a value? 1/2. 1 over 2 or 1/2. So negative, negative 1 is going to be positive 1. And half of 2 is going to be 1. So our x value is going to be what? 1. That's correct. So now we got our x line of symmetry. So where our x value is 1, or our line of symmetry is going to be at 1. So it's going to go right there. Remember, we don't have our vertex yet. All we have is our line of symmetry. We know it's going to cross through at that point. Your vertex is how high up or down it's going to be. Well, we got easier numbers to deal with. This is what I meant earlier when I said there were bad examples for your first one, because 1 is a whole lot easier number to plug in. When x's value is 1, we're going to find the y to make the vertex. So y equals 1/2 times 1 squared minus 1 minus 1. All that is that equation again with 1 plugged in place of x. So 1 squared is 1, and 1 times 1/2 is 1/2. Minus 1 is minus 2. So 1/2 minus 2 is going to be negative 1/2, or y equals negative 1/2, or negative 3/2. So when x is 1, y's value is negative 1/2. There's your vertex right there. Based on the equation, is it going to open up or is it going to open down? Is it positive or negative? It's positive. That means it's going to open up. It's not if it is a fraction. If is it positive or negative? This a value is positive, so it's going to open up. What number is easier to multiply by, 0 or 2? Absolutely 0. So let's shift one time to the left and say x's value is 0. So when we plug it into each of these parts where you have x right here, 0 squared is 0. 1/2 times 0 is 0. Minus 0 is 0. So you got y equals negative 1. That's what I mean by multiplying by 0. So when x's value is 0, y's value is negative 1 right there. So what about when x's value is 2? What do we know about y? It's the same. It's the same negative 1 as that one. What number is easier? We got to shift one more time. Is it easier to shift to 3, or is it easier to shift to negative 1? Negative 1, that's right. That's the number that's easier to multiply by. So we'll use one more and we'll say x is negative 1. So we'll run that equation one more time. Y equals 1/2 times negative 1 squared minus negative 1 minus 1. So negative 1 squared means negative 1 times negative 1, which is 1. 1 times 1/2 is 1/2. Negative 1 is plus 1, and then minus 1. So plus 1 minus 1 are going to cancel out. So y's value is you're left with 1/2. So when x is negative 1, y's value is 1/2. And then again, what do we know about when x is 3? Y's value is what? The same 1/2. Right there. It matches it. Now that you got 3 points on each side, you can draw your parabola just like that. And again, you don't have to draw it perfect. Just try to not be messy. Number 2, this one is in vertex form. Y equals negative x plus 1 squared plus 3. This represents your vertex. It's the opposite of 1, and it's exactly what 3 is. So your vertex is negative 1, 3. So at negative 1, positive 3, there's your vertex. Is this picture going to open up or down? It's going to open down. Your a value is here, negative 1. So we know it's going to open down. So let's use 0. Let's shift one time to the right and use the number 0. 0 plus 1 is 1. 1 squared is 1. And 1 plus 3 is 4. So when x is 0, y is 4. So at 0, 1, 2, 3. Wait, I made a mistake. Let me plug it in. It's not 4 because there's a negative up front because we know it opens down. So let's just run through it real quick. Y equals negative. We're plugging in 0 plus 1. So it'll be 1 squared plus 3. 1 squared is 1. Then the negative is going to come down plus 3. Y's value is 2. Notice what just happened just now. It's not, it wasn't 4 because if we would have got 0, 4, we know that that equation opens the other way since it's negative. So it's not that way. It's 0, 2. Remember, this is your axis of symmetry here. So we know if that one goes there, then this one goes there. It's the same. And then again, we got to shift one more time. Is it easier to shift to -3 or to 1? To 1, that's right. So shift one more time and use this value for x. X is 1. So negative 1 plus 1 is 2. So we have 2 squared plus 3. 2 squared is negative. It's going to become 4 plus 3. Y's value is -1. All I'm doing is working that equation. I'm just trying to do it a little quickly for the sake of time. So y is -1. So when x's value is 1, y's value is -1. And again, axis of symmetry, it's exactly the same on the other side. There's your equation. There's your picture of your parabola. And we'll pick up with intercept form tomorrow.